But most of you know how to factor, so there's hope. All right, so then we've got a sign chart. We'll put our df dx here. What are my critical numbers? And they are critical numbers because the derivative exists at each one of these points, and the function's defined at the point. So we've got x equals to 0, minus root 6, and root 6, right? Now, every so often, when I'm being careless, I'll forget to put them in order. Don't do this. This seems really stupid. You're like, I wouldn't do that, but you will if you're like a little bit sleepy or talking to a friend or checking Instagram, whatever it is. You checking the Instagram. You check the Instagram, or is it the TikTok? What is it you guys check? I don't know. TalkTick, Bookface. You just look at a clock.
Yeah.
Oh, wow, that's old school. I'm partial to sundials, but I'm sorry. Nerds everywhere I look. Let's see here. So, I'm just joking. You guys aren't nerds. Let's see here. So 0. The point is, I should put minus root 6 first, right? That's the one that comes first as we're going in the number line. It's important that you put them in the order that they actually appear in the number line. Otherwise, you will get really, really confused. I speak from personal experience. So there's the numbers in order. Now I need to plug numbers into the derivative formula to find out where it's increasing and decreasing. So let's see here. If we put in a very positive number, it's positive. Then each one of these factors is linear, so it flips signs at each one. There you go. All right. If I had one of these factors being squared, then you wouldn't flip signs. You'd actually stay plus to plus or minus to minus as you're going across the critical number. But we didn't have that, so. All right, so, and let's see here. I can also, for the sake of, if I'm going to make a graph, I like to put the sign chart, I like to stack them. I like to stack the sign chart for the derivative and the function. And next class, we'll start graphing, we'll start making the sign chart for the second derivative. That will give us the concavity. But I like to stack them so I have the story all told in parallel. So like square root of 6 is what? It's, it's about 2.4-ish. 2.45, something like that. Right, because 25 squared is 625. So the square root of 6.25 is 2.5, I think. So that's about it. And so my zeros are at 0.65. So the zeros are like back here somewhere, right? Which I'm not going to write. I'm going to write them as 0.6 and minus 0.6 just to be lazy. And what happens, what's the value of the function between plus and minus 0.6-ish? It's what? It's, I guess I can afford a 6.4. There you go, 2 digits. You happy? So look, f of 0 is minus 5. The y-intercept is minus 5. So it's negative up in here. Then it's going to be positive over here. And it's going to be positive over here. That's the deal. That's the big story for the function here. Does this function have any horizontal asymptotes? The answer is no. It's a quartic, so it just looks like this overall, right? It's like just like that. All right, so we can graph. So we've got zeros here and here. And what does that make? F of root 6 is what? Actually, I don't really care what it is so much. It's like 36 minus 36 minus 72 minus 5. Maybe minus 41 is like f of. Can somebody check that for me? What is f of? No, it can't be. It can't be negative. It could be positive. I should have got a positive. What's the square root of 6? What? Dude. I'm doing something wrong in my head. Oh, anyway, while I'm setting my thoughts aside, f of 6 is what? Local what? F of minus root 6 is what? So f of 6 is a minimum, maximum. F increases where? Part of what's messing with me is there's a minus here. So minus, no, wait a minute. So here, hold on a second. It's decreasing and then it's increasing. That's a local minimum. And over here, it's the same, right? They're both. They're both local minimums. On the other hand, f of 0 is a what? Yeah, minus 5 local maximum. Because there you've got increasing and then decreasing. So I won't draw this to scale or anything, but this is a local max. So we've got local mins here and here. What's messing me up is I feel like those should be positive. They've got to be positive. Why am I getting negative in my head? Can somebody check that for me? Oh. Oh. I did this wrong somehow. Oh. Look, guys. I see what the problem is. Check this out. You guys should have stopped me here. What's wrong here? Apparently, I would have also lost my points. So this I would like to look at as minus the square root of 6 plus the square root of 41 quantity squared. That's the logic here. It's a squared minus b squared. It's a plus b, a minus b, right? I'm factoring the minus out from both of them. It shouldn't be a minus here. It should be plus. So I saw that there was an error there, but I didn't go far enough because I should have had a plus here. And putting that plus here makes this actually quite big, comparatively speaking. It's actually, the zeros of the function are, excuse me, .52. So plus or minus 3.52. Those are your zeros. Okay, I feel much better. So I was getting really confused. I couldn't make sense of how the graph would work. And that's good. That's good because I couldn't have made sense because it was nonsense. So 3.52, the reason it didn't make sense is it didn't make sense. What do you know? All right, minus 3.52. All right, so my zeros are out here. And I wasn't wrong. F of minus root 6 and f of root 6 were negative. So roughly speaking, I've got these 1, 2, 3, 4, 5 points of reference. Let's draw the graph. let's draw the graph. How's it go? Well, we've got a local minimum at minus root 6 and root 6. We've got a maximum as f of 0. So the story is something like this. Oh, these are lower. That also matters. I think I got like minus 40 something for the f of plus or minus root 6. So let's see here. So the graph looks something like that. So with calculus, we can find the turning points for the graph, and we can actually graph quite. The only thing we could have discovered with college algebra is just the zeros, namely this like plus or minus 3.52. Yeah.
So there are no asymptotes.
Yeah, there's no horizontal asymptotes for this one because the limit as we go to plus or minus infinity is infinity, right? What's the global, like this is symmetric, I'm pretty sure. Actually, I'm not sure. Yeah. I do believe this is an even function, right? So f of minus root 6 is equal to f of root 6. So if I did this graph right, these should be on the same level. And those both give you the global minimum for the function. And so for what it's worth, the range of this function would be that value to infinity, right? The domain is everything. So you can see these things as well. So listen, graphing is not easy, but it is interesting. And a good example here usually takes 20 minutes. So I don't ask a lot of these on the next test. It's important that the one I do ask you can get right because I don't ask a lot of them, So anyway, I shut up. Thanks, guys.